All right. I have had good participation. I need sleeping beauties to wake up. I need people to put their phones away. And now I want to mention something else on the graphing before you write anything on the board at all. That's a sheet of graph paper. That's just going to be a regular one, not a trig one. Hey, could somebody mark this board like 5, 10, 15, 20? Is that a possibility that we could do them? Say yup. Yep. Okay. You know, and it would be a possibility. You know, you could have 100, 200, 300, etc. So is it possible to label graph paper differently for each and every problem? Yeah. All right. We are looking at our first graph. And what I'd like you to do, you might need a calculator to help. I don't know, you might not. So our first graph, I'm going to tell you this on our first graph. It is going to go up, I'm going to say, at most 2. The first graph, 2. So how about let's take care of this right now. Your graph paper has 4. So let's go half, 1, 1.5, 2. Say, I know. All right, same thing going down with the negatives. All right. I'm going to make a change on this one because I know what I'm going to do next. And I would like you, just like I mentioned just moments ago, and we're going to do it different going across because I know what's going to happen. And if you, in fact, would please label the very first one 90, and then 180, and then 270. You might need your calculator because that's going to get quite a bit bigger than it's gotten. All right? Just like regular graph paper, you could choose to do different. I'm telling you because I know what's coming next. Bless you. Bless you. 90, 90, 90, 90, 90, 90. Somebody help me out. On the sheet of paper I've given you, can you make it out to 810? Is that how far you can make it? Good. Okay, good. And let's go negative 810, please, also. So just like on a regular sheet of graph paper, if you were to change how the graphs are, or how the tick marks are 1, 2, 3, or 5, 10, that would change a little bit of sort of how the shape looked. Correct? Say yep. Yep. All right. So lightly, and this is not what you're going to put in the corner. We're going to do y equals sine of theta or sine of x. Okay. And so, on your normal, and you could have your other ones out for help if you need to, at 90 degrees, does the sine get up all the way to 1? Say up. Yep. All right. So we're going from 0, and then at 90 degrees, and then I'm sort of skipping the one in the middle is what I'm doing, and then going down to 180, and then down at 270. And at 360, and then I'm going to go a little bit more, and I'm actually going to go a little bit less as well. So we sort of, and if you do that, that's sort of your opening graph. That's sort of your opening graph.
Wait, what's 240 at?
I think it's 270. I think it's 90, 180, 270, 360, 450, 5.
Like the y.
It gets down to -1. -1. Cool. Now, does that graph appear more squished than it's appeared the last 2 days in this class?
Yes.
Okay. However, it's not really squished more, it's just on a different scaled graph. Say that makes sense?
That makes sense.
Cool, all right. And I did it for a reason. And I'm going to repeat once again, for the manyth time, that great thing Mr. Malarkey taught. And some of you are brand new to me, a few of you are, all right? And what he taught was he noticed his neighbor's kids, and here's what he noticed, all right? Outside, they did what they were supposed to, and they did things up and down. So one of the graphs we did, one of the last 2 days, is like I put a +1 after that. Say, yep.
Yep.
Okay? And what happened when I put that +1? It basically picked the whole graph up 1. Inside, Mr. Malarkey talked to his neighbor's parents, and the neighbor's parents said their kid was horrible inside. If they said go to the right, they went to the left. If they said take the trash out, they brought the trash in. And another thing inside, when the parents said stretch that out, they squished it together. And when they said, hey, squish it together, they pulled it apart, those kids. All right. Up in your upper corner where you have like the list of where it says f of x, where it says the name, say, I see that. Please write y equals sin, parentheses, 1/2 theta, or 1/2 x. Is that inside? Yes. And does that appear the 1/2 like they're saying, hey, please squish that together? But they don't squish it together. They do the opposite. Instead of squishing it by half, they're going to double it. So would all of you do this in your bolder pen? And I should have hit that, but at 0, it's still 0. Now, at 90 degrees, it hit the highest point. This is easy. Don't calculate, what's double 90? So now over the 180, would you please put a dot? All right. At 180, it got back to 0. This is easy, no calculator. Double 180. What's 180 doubled? 360. All right. All right. The number, you're looking at it, you can see the number right there. What's 270 doubled? It's the number staring right there. What is it? 540. So -1, move that over to 540. And finally, let's see, it gets done in 360. Double 360, it's what? 720. And I'm going to go back just a little bit. So in fact, in the black pen, if you do this nicely, the graph is going to come and, in fact, does that look as if it has been stretched out twice as far?
Yeah.
And that's what it's supposed to look like, okay? Because, just forget about Mr. Malarkey's brilliant thing. When you're inside the parentheses and it says to multiply, you actually divide. When it says to divide, you multiply. Okay. All right. I need to add a new word. Please write, you could probably fit it under the word fx, right up near the upper left. Write the word period, P-E-R-I-O-D. And please do not write fifth period, even though we're in fifth period. The period says, how long does it take to repeat itself? Normally, sine takes 360 degrees to repeat itself. But please look at this graph and the numbers. In the black graph, it takes how long to repeat itself? There it starts repeating, doesn't it? Does it take 720 to start repeating?
Yeah.
Please write period 720 degrees. Wow, if it was 720th period, wow, we'd be here a long time today. All right, thank you very much. All right, look at the children outside now. All right. In fact, quickly check your phones because I have to stop this recording and start a new recording because QuickTime only lets me record 10 minutes at a time. And that took 10 minutes.